I'm going to explain the Huntington Hill method only using shapes and lines. And the only shape I'm going to use is a rectangle. So here's the starting line, and you're going to start giving seats to a big state and a small state. And you're going to give a seat to a state by drawing a rectangle. So you got the big state and the small state each having a rectangle, and the rectangles are equal area. And so because the small state, the length of this line I drew for the small state is the number of people in the state, so it's a bigger line for the bigger state. So that means that because these are equal area, an area divided by one line gives you the other line. This direction is actually the value of that person from that state's vote. So it's one seat in Congress divided by number of people from that state. So for a small state, that's a bigger number. And so for Huntington Hill, you want those numbers to be close together for all the states. And to do that, you kind of make the midpoints close between these blocks. I'll explain what that means. So it's easier to start with the Webster method, which is linear, and then Huntington Hill is just using a log on that. Start off with drawing the midpoint for each of these little blocks. And the next seat goes to the state with the lowest midpoint. So what I mean by that is that this midpoint is not as far along the line as, say, this state's midpoint, or this square's midpoint. So if you find the next midpoint, it would be the big state's midpoint right there. And that's pretty even, right? The vote value is basically right there. The way you're able to minimize that distance between the two vote values, which is like this little tiny amount, is actually by choosing that midpoint that's the closest to the starting line. So the next one would be for the big state to get a vote or a seat. And you can see here that this vote value, V, is it's somewhere in between that the two these two lines here, and so it's to the right of this midpoint. So that means the state gets that seat, and it's to the left of the next midpoint for the other states. So if it's to the right of a midpoint, then that state got the seat, and if it's to the left of a midpoint, then that state did not get the seat. And that's how you find the vote value. It's not a certain value, it's kind of a range of values, but that works out. And that means that the distance between the two vote values for the two states is going to be kept at a minimum. And this works for even more states. Huntington Hill is different because it actually minimizes that value relative to the total value that all the states have. I guess the biggest value, something like that. And the way they do that, they don't divide by that value. They actually just take the log of this whole thing. And that gives you, instead of the mean or the midpoint, it gives you the geometric mean. So that's why I use the geometric mean in Huntington Hill. And that pretty much explains it, just using just some lines and some squares.